Hello and welcome to Nikolay's genetics lessons, and today we are going to talk about false positive and false negative Bayesian statistics. And here's a problem. A drug screening test is used in a large population of people, of whom 3% actually use drugs. Suppose that the false positive rate is 2% and the false negative rate is 4%. Thus, a person who used drugs tests positive for them 96% of the time, and person who does not use drugs tests negative 98% of the time. What is the probability that the randomly chosen person who tests positive for the drugs actually use drugs? As usual, I recommend you to pause video here, try to solve this problem on your own first, and when you would be ready, you can run video again and you can compare your answer with my answer and explanation. Take a look. The whole population is divided to two categories: those who use drugs and those who don't. And we know those who use drugs make 3% of the whole population. So those who use drugs make 3% of the population. That means that the rest 97% of the population don't use drugs. So we put don't here and do use drugs here. Next, suppose that the false positive rate is 2%. So where we can find false positive? In those people who don't use drugs but may test false positive. So 2%, and the frequency of this category is going to be 2% times 97%. So basically we have to multiply these two numbers, and this is going to be a frequency of those people who would be falsely positive. If 2% would falsely test positive, that means that 98% would test negative. So they don't use drugs, and tests show that they do not use drugs. 98%. Again, we have to multiply these numbers, 98% and 97%, and this is going to be true negative. Let's read our problem again, and the false negative rate is 4%. So who is going to be false negative? Those people who use drugs, but due to inaccuracy of the test, 4% would be false negative. They use drugs, but test shows that as if they don't use drugs. So 4%. So we put 4% here. Again, frequency of this category is going to be 4% times 3%. So we have to multiply these two probabilities, and this is going to be false negative. And if we have 4% here, that means that 96% of the people who do use drugs, after the test, the test would show that they use drugs. So this is going to be true positive. And the frequency of this category is going to be 96% times 3%. Again, next sentence. Thus, person who use drugs test positive for them 96%. Use drugs and 96% would be tested positive. And next statement, a person who does not use drugs tests negative 98% of the time. So person who doesn't use drugs falls into this category, and 98% of the time when he used test would test negative. So true negative. And the question: what is the probability that a randomly chosen person who tests positive for drugs actually use drugs? Who is going to test positive? This is true positive, so people who use drugs and test positive for drugs. But also we have false positive, people who don't use drugs but still test positive for drugs. Both these categories would test positive for drugs. So with the next step, we have to divide number of people who true positive by total number of people who test positive. In other words, what we have to do, so 0.96 times 0.03. So I convert these percentages into decimal numbers and we have to divide. So this is true positive by total number of people who test positive. Again, this is going to be those who are truly positive, so 0.03, and falsely positive, which is this category. So this is going to be plus 0.02 times 0.97. And our answer is going to be 0.77. Or if we need an answer in percent form, we have to multiply by 100. And our answer is going to be 77%. So this is our answer. So as you see, the first impression would be if accuracy of the test would be 96%, if someone would test positive, then probability would be 96% that this person used drugs. Actually, as you see, according to our calculations, this number is going to be 77%. And this is all for today. Subscribe and see you in the next video. Goodbye.